Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this part 4 video, I will solve 5 conceptual problems from the chapter of probability, these problems are based on empirical formula of a probability. This is set 1 of 5 conceptual problems. I will keep on making more sets so that you have a good practice of solving conceptual problems on the chapter of probability. So this video is part of the playlist CBSE Maths for Class 9 following the textbook of author R.D. Sharma. If you find this video if you find this video beneficial and then please like it, share it share it with your friends, and once again if you want to further support me, then subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 4 video where I will be solving set 1 of 5 conceptual problems on probability. Okay, so the first problem says that events E1, E2, E3 are the only possible events of an experiment and their probabilities are recorded. Which of the following can be the possible correct answer? Which means that which of the possible probabilities of E1, E2 and E3 are valid. Where it is given that E1, E2 and E3 are the only possible events of an experiment, means that E1, E2 and E3 are all the elementary events of an experiment. So we know in that case we must have probability E1, the sum of the probability of all the elementary events of a random experiment is always equal to 1. So we must have this. We have to check this for all the given choices. Also, this is one thing, and also any individual probability must lie between 0 and 1. That is, it can be greater than equal to 0 or less than equal to 1. So for any probability of any event for a random experiment, that event could be elementary event or even a compound event, probability always lies between 0 and 1. So we must also check this. Okay, let's see choice A. E1 is 0.3. Okay, for E1 is 0.3, that is fine. It is greater than equal to 0, less than equal to 1. E2 and E3, probabilities of E1, E2 and E3 are all greater than equal to 0 and less than equal to 1. So this condition 2 is satisfied. Now we have to check condition 1. Condition 1 is sum will be equal to 1. So 0.3 plus 0.4 plus 0.3 is indeed equals to 1. So definitely choice A is the now it is saying that which of the following can be the possible correct answer. Okay, now I am not sure whether this is a single correct choice problem or multiple correct choice problem. Anyway, we will see all the choices. Choice A is correct. Let's see choice B. Choice B 6. Choice B is not correct because this is correct. Choice B is not correct because we can see that the sum of the probabilities of the elementary events is not coming out to be 1, as 0.2 plus 0.4 plus 0.3 is equal to 0.9, which is not equals to 1. So this is a false statement. This is a false statement. Choice C. Choice C is incorrect because probability of E2 is equal to given as minus 0.3. This is less than 0. No probability of any event is always greater than equal to 0 and less than equals to 1. So obviously choice C is incorrect. Choice D, it is all the probabilities are greater than equal to 0 and less than equal to 1, but we can see that the sum of the probabilities 0.4 plus 0.1 plus 0.3 is coming out to be 0.8, which is not equals to 1. So this is also incorrect. So the only correct choice is A. So always remember that for any random experiment, if you are given that some events are all the possible events or possible events or outcomes, it also means that they are all the elementary events, and in that case the sum of the probabilities of all the elementary events of a random experiment is always equal to 1. Let's see question number 2. The probability of guessing the correct answer to a certain question is x by 3. If the probability of not guessing the correct answer to the question is 3 by 4, then x equals. Now you must remember that what is the experiment here? You have to guess the correct answer. Now the experiment here, what is the experiment? Guessing the correct answer. Guessing the correct answer, and what are all the possible outcomes or all the elementary events? The elementary events are, if I consider A and B, there are only two possible elementary event or two possible outcomes. You will guessing either you will guess the answer, not guessing the correct, but guessing the answer. It will be guessing the answer. Guessing the answer. So either one elementary event is that guessing the answer correctly or guessing the correct answer. This is one possibility, and the other event, elementary event, is that guessing the incorrect answer. Guessing the incorrect answer. So these are the two elementary events of the random experiment of guessing the answer. So quite obviously we must have PA, probability of A plus probability of B, must be equal to what? Because A and B are the all possible elementary events, or not all possible. If I say that A and B are the elementary, yes, we must say A and B are all possible elementary events of a random experiment, then we must have probability of A plus probability of B equals to 1. Now it is given that the probability of guessing the correct answer to a certain question is x by 3. So it is given that probability of A is given to be x by 3. Okay, PA we know is equal to x by 3. And it is also given if the probability of not guessing the correct answer, which is B, the event B is not guessing the correct answer. It is, and its probability is given to be 3 by 4. So we must have now x by 3 plus 3 by 4 is equal to 1. We got a linear equation in x, we can easily solve for x. If I simplify this will be 4x plus 9 by 12 is equal to 1. This implies 4x plus 9 is equal to 12. This implies 4x is equal to 3. This implies x is equal to 3 by 4. So x must be equal to 3 by 4. 3 by 4. So 3 by 4. Okay, so 3 by 12 plus 3 by 4 is equals to 12. Okay, so the correct answer is 3 by 4. Choice B is the correct answer. Let's see question number 3. If probability of event E1, E2 and E3 are events, if probability of E1 is 1 by 6, probability of E2 is 1 by 3 and probability of E3 is 1 by 4, where E1, E2, E3 and E4 are elementary events of a random experiment. Okay, I think if you are given that certain events are elementary events of a random experiment, then it will mean that they are all the possible elementary events. So in this problem, E1, E2, E3 and E4 are all the elementary events of a random experiment. Then we are asked to find the probability of E4, where the probability of E1, E2 and E3 are given. Okay, so we know that the sum of the probabilities of all the elementary events of a random experiment is equal to 1. So we must have probability of E1 plus probability of E2 plus probability of E3 plus probability of E4 should be equal to 1. Now putting the values of the given probabilities of E1, E2 and E3, we have 1 by 6 plus 1 by 3 plus 1 by 4 plus, if we don't know, we have to find probability of E4 is equal to 1. Now simplifying this part, this is 2 plus 4 plus 3 divided by 12 plus probability of E4 is equal to 1. Sorry, this implies probability of E4 will be equal to 1 minus 7 by 12, which is 5 by 12. So the probability of E4 is 5 by 12, and I think there is no 5 by 12 in the given choices. Let me check if I did any silly mistake or not. P1, so 1 by 6 plus 1 by 3 plus 1 by 4 is 12. This is 2, 4, 3, 6, 9. So this is 9, sorry. This is not 7, but this is 9. 9 by 12. 9 by 12 after simplification becomes 3 by 4. So this is 1 by 4. So the probability of the event E4 is 1 by 4. So the correct choice is D. D is the correct choice. Let's see the next problem. Question number 4. A coin is tossed for a certain number of times and it was found that the probability of getting a head is X, where X is given to be the value of X is between 0 and 1, and it appeared by times. Then the number of times the coin was tossed is. So a coin was tossed for a certain number of times. So let's say let coin was tossed, let's say n times. So what information is given? It is given that it was found that the probability of getting a head is X and it appeared y times. Let's say if I tabulate the given information outcome, since a single coin was tossed, it will be outcome can either be head or outcome can either be tail. Now the frequency, we need the frequency to calculate the empirical formula. It is given that head appeared X times. Now the toss, we have assumed that the coin was tossed n times and head appeared X times. So quite obviously tail will appear for n, tail would have appeared for n minus X times. So now we know how to find from this information, from this frequency distribution, we know what will be the probability of getting head. So probability, let's say instead of head I am denoting the outcome as head as capital H and tail as capital T. So what will be, using the empirical formula, what will be the probability that when a coin is tossed, head will appear? Based on this information, it will be X by n. X by n. Okay. I'm sorry, in the problem it is given that the probability of getting a head is X. So X is not the frequency, Y is the frequency. I'm really sorry, Y is the frequency. Head, we have assumed the coin was tossed n number of times and it is given that head appeared Y times. So the frequency of appearance of head is y. So the frequency of appearance of tail will obviously be n minus y. So now the probability, if when a coin is tossed, the probability that it will be head will be now y by n, will be y by n. So it is given that y by n is the probability of head is given to be x. So clearly we can say that n will be equal to y by x. Even though this problem is very simple, you might be able to solve this orally, but I thought I would explain it properly. Okay, so the number of times the coin was tossed is y by x. So the correct choice is B. Let's see question number 5. I think this is the last problem. Yes, question number 5. In a random experiment, a compound, this will be compound event. In a random experiment, a compound event E is the collection of elementary events A, B and C. Then which of the following statements are correct? It is given choice A as probability of A plus probability of B plus probability of C is equals to 1. Choice B. Okay. Now it is given that the compound event E is the collection of the elementary events A, B and C. But this does not mean that A, B and C are the only elementary events of the random experiment. There could be many more elementary events of the random experiment. There could be D, E, F. It is only saying that the compound event E is the collection of elementary events A, B and C. That is, this means that if any of the event A, B and C occurs, then it will satisfy the condition of occurring event of E. Now this does not imply for sure that the event A, B and C event does not imply that A, B, C are the only elementary events. There could be many there could be other elementary events, which means this does not imply that probability of A plus probability of B plus probability of C will be equal to 1. This will be true only when A, B and C are the all possible outcomes of the random experiment, or A, B and C are the only elementary events of the random experiment. So choice A is not correct. What about choice B? Choice B is correct, because when a compound event E is a collection of elementary events A, B and C, if we always have, it means that the probability of the compound event E should be equal to the sum of the the sum of the probability of the elementary events in the collection of the compound event. So this will definitely be true. Probability of E should be equal to probability of A plus probability of B plus probability of C. This is by definition, because A, B and C, elementary A, B and C makes the collection of elementary events A, B and C is defining the compound event E. So definitely choice B is correct. What about choice C? It is given saying that probability of E plus probability of A less than equals to 1. No, not necessarily. Probability of probability of E plus probability of A less than equals to 1. No, because if there is a compound event, the sum of the probability of a compound event and an elementary event could be more than 1. Could be more than 1. For example, let's say for example, ABC are the only possible elementary events of a random experiment, and let's say we have probability of A is equal to, let's say probability A is equal to 0.8, probability of B is equal to probability of okay, 0.1, and let's say probability of C is equal to 0.1. Now clearly this will imply the probability of E, since A, B and C, you can clearly see, since the sum of the probabilities of the elementary events A, B and C is coming out to be 1, then this means that A, B and C are the only elementary events of a random experiment. In this case, if E is the compound event, which is the collection of the elementary events A, B and C, then probability of E will be probability of A plus probability of B plus probability of C, which is equal to 1. Now probability of E plus probability of A will definitely be greater than 1. So the probability of a compound event and the sum of the probability of a compound event for a random experiment, the sum of the probability of a compound event and an elementary event need not be less than equal to 1. It is highly possible that its value will be greater than 1. So that is all for the set 1 5 conceptual problems. You must you must understand the concepts to solve this kind of problems. This will clear your the foundational concepts from the chapter of probability. Now I will keep on. I will try my best to solve all the problems from the textbook of author R.D. Sharma, as well as the supplementary MCQ problem book, and in between I will also try to solve this kind of conceptual problems, so that there is a good coverage of good variety of problems from the chapter of probability, from easier to medium and high order thinking problems. So please stay tuned for more videos to come from this chapter of probability. I am ending the video here. Thanks for watching, and until the next video, take care and bye.